Humpty Dumpty. Okay, looks like we have an easy, actually a very early one it looks like, so probably even easier given difficulty inflation. Given a binary tree, determine if it is height balanced. Height balanced being in which the depth of the two subtrees of every node never differs by more than 1. So I guess this is height balanced. Because from here, the depth is 2, and this is not height balanced. Interesting. So I think this is just probably recursion, although maybe I can do one that is not recursive. Sometimes you would need to do a non-recursive one if there's too much on the stack, but generally that's not really an issue. Also, non-recursion might be slightly slower in some instances than non-recursive formatting using a for loop. But let's just do the recursion. Logic feels like if so I think it needs to recurse and maybe return the longest depth of the longest, return the length of the longest, return the longest length between the node and its farthest child, at which point like this 2 would return 2, and then this 1 could compare like 3 versus 1 and determine that's not height balanced. So version to start, let's say recursive method node returns the length from it and its farthest child. Actually, it needs to return that plus the fact that it actually needs to return 2 information, right? And whether or not that causes it to be not height balanced. Is if the first node returns the length of that and its farthest child. I guess I could do 2 recursive functions and return both and do a comparison between like the longest and the shortest. No, that's stupid. I think I'll do a 2-parameter return. Node returns and whether it's height balanced. So I can call on the root node with that. So let's say define kind of process on the node. It should be a tree node. And how do I do 2-parameter return Python? Syntax for 2-parameter. This could just be a tuple. 2-parameter return in Python 3. It's called Python 3. Is it called Python? What's Python 3? This doesn't really have the. Okay, it's just returning a tuple, huh? Is it returning a list in that case? It's returning a tuple. What is the syntax? Okay, so tuple int. So it could be int and boolean. Alright, so to process it, it needs to process both of its child. So I guess if the node doesn't have any children, if not node.left and not node.right, I guess I could do something if not node, if the node is null. Does that make sense? Yeah, whatever. Not node.left and not node.right, then you process both. So left int left bool is equal to process on node.left, right int. I guess it should probably be more clear. Left depth and left balance is that right depth and right balance is in processing. Shucks. What if one of them is null? Okay, actually I just need to handle the null node case. If there is nothing here, then return, I guess it would be 0 depth and true, I guess. Capital T true. And then otherwise there is a node here, right? Now I need to check if there, I need to do the if. No, actually I can just process both, because then if it's empty then it's null, and then it just does it. So left depth left balance is equal to process node left depth right balance is equal to process node right process, and then max depth is the maximum between left depth and right depth, and then I don't really care about balanced unless this is the top node, in which I do care about balance. I guess it's just the comparison, right? So I guess I don't care about this return value, because that balance is just for the first call on the root node. So if right depth, I guess the difference, right? If the absolute value of left depth minus right depth is greater than 1, then balanced is false. I guess I can make this, just assign it to the expression, the evaluation of this expression is not this. Balance is if it's less than or equal to 1. I guess it's less than 2. And then return max depth and balanced. And then in my main method, I'll just call return, guess I could just ignore the max depth. Balance is equal to process on this root node, turn balanced. Wonder if I can actually just do like bracket 1. Oh, I'll try that. This is wrong. Case 2. So I think I said this is balanced even though it's not. Huh. If the absolute value of the difference between the depths really. Oh. Okay, so let's just process this there. So it calls it on the root node, and then that root node calls it on this and this, and then it calls it on this, calls it on this, and it calls it on this. Oh, I'm an idiot. There's no way that I'm actually tracking the depth. Yeah, what is this max depth? What is this? Oh boy. Oh boy. It returns the max depth, but it should bump it up by 1 each time, I want to say. The left depth is increased by 1, the right depth is increased by 1. I think it should be just increased by 1 each time. Okay, I think that might be fix. Okay, there we go. Silly, silly, silly. Actually, I think maybe this syntax should work to impact the top. And then I can just return that value. Okay. Amazing. Amazingly poor. Okay. Thank whoever added this tree visualizer. So 1, 2. And I said no, even though it should be yes. I said yes, even though it should be no. And what's depth of the subtrees of every node never differs by 1? The depth of every node never differs by 1. Binary tree is a binary tree, or the depth of the 2 subtrees of every node. Never differs by 1. So what's going on here? So I said that this is my code returns true, so it thinks it's balanced, even though it's definitely not balanced, right? Like this node, this 2 has a 0. Let me see. I just returned the balanced part. Okay, yeah. It's not needs to override it. It needs to override it. So if it's false, then it makes the whole tree false. So I do need to keep track of this. So right balanced or left balanced and right balanced. And balanced here. So this is going to be, if this is false, then this is going to be, and it makes it all false. So it should be just a bunch of ands because false should falsify everything. So it'll be left balance and right balance and balanced. Interesting. That works. It's not very fast, huh? Although I am using recursion. The logic here seems okay. Logic here seems okay. I guess I could try to do the non-recursive way using like a stack. Stack would be nice because then you can just short circuit everything. You can just return false whenever you see something that's wrong within the subtree processing. Okay, so I will go ahead and make this practice for non-recursive kind of formatting of recursive general ideas. So I think this should be, the stack should start with a process stack should be starting with the root node. And then I want to make this breadth first search or depth first search. Depth first search is generally going to be a stack, and breadth first search should generally be kind of alternating layers or deleted queue. All right. No equals process dot pop. So then when I process it, how would this work? Needs to somehow compare both the left side and the right side of the node. So it would push onto the stack left and right. And then we push onto the stack both left and right. And then somehow we need to compare those results from when those things get processed. Compare those results when those things get processed. So 3 pushes 9 and 12 in the stack. Maybe the 9 gets processed using a deck. 9 gets processed. Then the 20 gets processed. But the 9 would need to process its own thing in order to figure out what its depth is. I think 3 pushes 9 and 20. 3 pushes 9 and 20. Do 3 pushes, let's say 9. how do you, what is the first time that you can tell that it's not balanced? So this thing's balanced. This thing's balanced. This thing technically is balanced. So the 1 is the thing that the 1 is the only node that tells it it's not balanced. Because everything else is within one of the heights of the sides of it. 1 is the thing to tell. 1 pushes these two nodes. This node pushes these two nodes. This node pushes these two nodes. This node pushes these. Looks like it'd probably be breadth first search. 1 pushes these two nodes. 2 pushes these two nodes. The 3 pushes these two nodes. And then when it pops, it goes back to its parent. When it pops, it goes back to its parent. Oh man. This is easy all the way up until when it's actually hard-ish. Non-recursive ways is actually quite difficult. Well, maybe I'm just not used to it. Seems like I need to know the reference for the reference to the parent at some point. The parent. I need to know the reference to the parent and whether or not this is like the left child or the right child of the parent. So I need to put a tuple on the stack rather than just the node. I can put a reference to the parent node and then verify whether or not in this parent node it's the left side or the right side of the parent. And then so it'd be something like the node itself, parent node, and then whether or not this node is the right side or left side. So let's say the node parent and is left. So then it needs to process. It needs to pop. It needs to push both the. Well, if the node is null, then oh boy. The node is null, then it needs to do its parent node, then I think it needs to just it needs to do something like it needs to add a parameter to the parent, add a variable to the parent that states that this side is so if is left parent dot left depth is equal to 0, else parent dot right depth is equal to 0, and then continue. So now This is an actual node. If this is an actual node, it needs to it needs to use the stack to process both of its children. So then it needs to know that when it's traversed those things. Okay, so I think I need also a set of things that have been processed. There's a set of nodes. So if this hasn't been processed, if this node hasn't been processed, or maybe I should just call it scene, because it's not. The first time it sees it, needs to add its children to the process stack, and then after that, it needs to just not do this. So if not in scene add this node, we have node scene.add this node, and then process appends the left side of the node. There's left child. Needs to be a tuple. Node left. Parent node is itself. Is left is true. And then process appends node.right. Node itself. False. Also needs to carry back. No, it doesn't need to carry back the balance point, because I think it's going to just return false in the balance point. So then it continues here. So otherwise, this is the second time encountering the node. If it reaches this stage, so at that point, the left and right depth are assigned by its children. The left and right depth should be assigned by its children. So it needs to assign its own. Is that right? If it's an actual valid node. Yeah, it needs to determine. So it needs to do the determine max depth based on its children assignments of its left depth and right depth. And here, if it's not balanced, if actually it probably needs to do this prior, if the absolute value of its difference between the two depths of its left and right side is greater than 1, then return false. So anything time. So this is kind of the way that this is better in terms of efficiency than doing incursion, because it's going to short circuit immediately. Otherwise, it needs to figure out its max depth, and then it assigns its parent space on this. If is left, then parent left depth is equal to, I'm going to say 1 plus max depth, or max depth plus 1, else parent dot right depth is equal to max depth plus 1. And then this doesn't quite work for the first node, I want to say. For the root node, add it to the stack, because the root node would be would not have a parent. So I could do a dummy node there. Could do a dummy node there. Or I could also do root node. No, root node definitely shouldn't be seen. What's the right way to handle the root node? I could also do I can do a check without the parent is null. Seems a little questionable. Isn't that I'd be doing that every single time? I could just make a dummy parent node. Deadbeat parent. This should be a tree node. The value, I think it matters. -1 for the value. Left is the root node. And then this would just use the dummy parent. I think that's fine, and otherwise this returns true. See where this crashes or doesn't crash. Amazing. So the two cases that I originally failed on the first go around is still this. Then this is always returning true. So it's not returning false. Interesting. So let's go ahead and what is it saying right here, I guess? So this process, yeah, so I think I probably should do here node.value. Node.left and node.right. Why is there two twos here? What's going on? And what is the point of having the value here? Node.left depth and node.right. What is it giving me? It's not giving me anything because it never reaches this stage, really. It's never reaching that stage. That's weird. What? Node is not in scene. Scene add the node. So it's not. I think it's just going straight here, is my guess. It's not node. There is a node. Let's skip it. Suppress. Change the top. Change the parent. Continue. Right. 327. Interesting. And it crashes when it tries to do this one on the none here. So none here. This would go back saying that the right def is 0, the left def is 0. So it does get here. And then the 7 should have definitely gone here. Node not been seen, so should skip this one the second pass now. Seen, if node not been seen, add the node. So here's, it has seen it, so it's the second time it's been through it. So why doesn't it print? Oh, oh my god. Idiot. Well, I guess this is good practice. I need to push itself onto the stack. Otherwise it doesn't ever process itself again. So what would it push into the stack? Node parent is left. Yeah. Pushes this own tuple again. I guess I should probably store this tuple. I guess, can I do this? Can I say, right? I should have better try that syntax, even though it doesn't make a lot of sense that would work. Always had, yeah, interesting. Learn something new. Okay. Excellent, excellent. Extremely slow. Extremely slow compared to the previous. Twice as slow. Takes twice the time. I guess twice as time doesn't mean it's twice as slow, is it? I guess it does, actually. But on the flip side, this does work. Interesting. Okay, okay. Not exactly great efficiency-wise, but is that just random? It's probably not random. This can't be from 0 to 6. Well, that 3 to 6 is random, I guess. I don't know what the 0 millisecond case would be. Okay, anyways, this is interesting. This is the non-recursive stack. I guess this is depth search with this, yes, depth search stack method for this problem. I guess I will go ahead and just comment it out. And this is the, this would be the time recursive, also depth search. And the way of it. And it seems, I mean, right balanced, left balanced. Yeah, I think you do need all those values. Getting back, I wonder if there's a better way of handling this. The logic here. I mean, you can say here, you can immediately say if either of these are false, so if either right balance or left balance is false, you can just immediately return false at that point. Return false with any, without really thinking about it too hard. If either of them are false, so if not left balance and right balance, or I guess maybe something like if not right balance and left balance. So it doesn't really matter what you return for the int. Like you don't even process it at that point. Otherwise you do process it. So you need to care about this. And this is just going to evaluate to balance because the other two are true at this point. I guess this might be slightly improved logic-wise. I don't know. I don't know. Whatever. So the summary here is going to be first method knows returns the length of it for the child and whether it's balanced. If any node returns not balanced, that overrides all kind of other calculations as whole tree would be not balanced. Otherwise, compare the return values for depth of left and right child and determine return parameters from that. So yeah, so kind of an unusual helper method to do the recursion, this process method, as it does. You do need to have two kind of pieces of information that you return from any node in the recursion, particularly the depth, in order to consider whether or not to check whether or not the node itself is balanced, and then also whether or not the nodes themselves are balanced. So, alternatively, you can use a stack, and process stack. To iterate over nodes, it's non-recursion. Since the processing needs to occur on or after the node's children set their values, use a scene set plus proper kind of calling kind of appending to the step in order to ensure double traversal of each node, like one's going down, one's going up. I think there was some hard problem where I had to learn that shit. But basically, you generally have a stack of a node, or in this case a tuple that has a node. On the way down, you check to see if it's seen. If it hasn't been seen, then it's on the way down. And then you add that node to the scene set, and then you add both that same tuple for this node along with its children onto the stack. Again, you're using a stack to do depth first search. This thing will get popped on the stack, and then this thing will get popped on the stack, and then this last itself is going to get popped on the stack at some point. And the next time this gets popped is when it's not seen, or when it's already been seen. So it won't execute this kind of downwards traversal, and it'll do like this upwards traversal where it can reliably use whatever information the node or the children kind of found out. So on the child, so since the children found it out, then you can evaluate what the children found out. So the children assign these two, and then you assign that appropriate value to the parent node. Anyways, this was definitely not that easy. I guess the recursion was easy-ish. This one is definitely, I consider medium, to be honest. Anyways, time complexity, this should be O of n, where n is the number of nodes. Since every node might need to be processed, recursed on in order to determine if the tree is balanced. In theory, like you might never, it would need to, traverse through every node and say that the tree is really balanced. So basically that's basically O of this O of n, since either method, kind of the recursion, or the stack method will possibly have kind of all nodes on the stack or on the call stack or the array.